Hi everyone. A water container is made in the shape of a cylinder with internal height h centimeters and internal base radius r centimeters. And we're going to answer all these questions here for Math IB practice for math studies. So the first thing we want to do is for 4A is to write down the formula for area of the surface area. So that's going to be A equals pi r squared plus 2 pi r h. All right, so that's part A. The volume of the water is 0.5 meters cubed. Express this volume in centimeters cubed. So basically, to convert from centimeters to meters to centimeters, there's 1 centimeter to 100, 1 meter to 100 centimeters. So for part B, you're just going to take 0.5 times 100 to convert it, but we have to cube it because it's this is cubed. So that's going to equal 500,000. All right. Then next it says, write down in terms of R and H an equation for the volume of this water container. So that's going to be volume equals pi r squared h. So we're going to write 500,000 equals pi r squared h. All right. Now for 4D, it says show that area equals pi r squared plus 100 or 1 million divided by r. So again, we have we already know that 500,000 equals pi r squared h. So we know that h equals 500,000 divided by pi r squared. And we know the area equals pi r squared plus 2 pi r h. So for h, we're going to substitute for h and plug in h. So h is 500,000 divided by pi r squared. Now when you simplify, these pi's will cancel and 1r, that will make that 1r. So we're left with area equals pi r squared plus 1 million divided by r. So we've shown this. Now it says the water container is designed so the area to be coated is minimized. So we're going to find the derivative of the area with respect to r. So we're going to take this and I'm going to rewrite this and move this r up and make it -1. So I'm going to write this as area equals pi r squared plus 1 million r to the -1. Whoops, -1. Just get it out. Now, we're going to take the derivative of a with respect to r. That's going to be 2 pi r minus 1 million. I got to put the zeros in or I won't get it. And then you subtract 1, so this is r to the -2. So this is going to equal 2 pi r minus 1 million. All right, divided by r squared. All right. Now it says, using your answer in part E, find the value of r, which minimizes a. So what that means is we're going to set this derivative equal to 0 and solve. So I'm going to go ahead and add this part to both sides. So you get 1 million divided by r squared equals 2 pi r. Now, if you simplify this further, I'm going to cross this up and divide by 2 pi. So I get 1 million divided by 2 pi equals r cubed. Now to find this value, you cube root both sides. And when you do that, you're going to get r equals 54.2 centimeters. Or you can write that as, for IB, 4.19, 19, trying to look at my calculator, 1926 ... Whoops. All right, so now it says, so that's for G. Then it says, we found the R. Now we have to find the value of this minimum area. So that means we're going to plug our R in back to our equation and do that. So basically we're plugging it back into this equation. Area equals pi r squared plus 1 million divided by r. So we're going to plug in our value. Pi is equals pi. And if you, the more you can put all the decimals in, the better. If you can do this all together, squared plus 1 million divided by r, which is 54.1926. And that's going to give you 27700 centimeters squared. All right. Now, finally, it says 1 can of water-resistant coats a surface area of 2,000 centimeters square. Find the least number of cans of water-resistant material that will coat the area in part G. So for that, you're going to take this was rounded to significant figures. So what I want to do is take our actual number was 27679. So I'm going to take that 27679 divide by 2,000, and that gives you 13.8395. Well, you can't have that many cans. So we want the least number of cans. So that means you're going to round up. So that would be 14 cans. And that's it. Thank you. Have a nice day. Bye-bye.